Hi, I am Gomati, Assistant Professor from the Department of EEE, St. Joseph College of Engineering. I have 10 years of teaching experience, and my area of specialization is power electronics and drives. And in today's lecture, we are going to see about the electrical drives, the basic components of electrical drives, what are the advantages of electrical drives, right? So first, to start with, what is a drive? Any system which is employed for motion control, we call that as drive. We have two types of drives, like mechanical drives and electrical drives. The main component of any drive system will be a prime mover. And this prime mover can be a steam engine, petrol engine, diesel engine, or hydraulic motor, or it can be an electric motor. So if the prime mover used or steam engine, petrol engine, or diesel engine, or hydraulic motor, then we call those drive system as mechanical drive. And the system which uses electric motor as a prime mover, we call that as an electric drive, right? So as I said, we have two drives, mechanical drives and electrical drives. So what are the advantage of this electrical drive over the other drive system? So advantages of electric drive. So the first advantage is the flexibility in control. Flexibility in control. That means it has a wide range of operation, right? It has a wide range of speed, torque operation, okay? And also, we can easily shape the speed torque requirements of a motor as per the load requirements. That is the main advantage of electrical drive. And second advantage, we can say it is eco-friendly. That means there is no pollution if you go for an electric drive compared to the other drive system, right? Third advantage is, since the power required is electrical, which can be easily generated, stored, and transported, okay? The input required is electrical, which is easy to generate, store, and transport. Following that, it can also provide all the 4-quadrant operation, right? So the 4-quadrant operations are like forward motoring, forward braking, reverse motoring, and reverse braking. So by using electrical drives, we can achieve this 4-quadrant operation. Adding to this, we can say the next advantage of using an electric drive is low losses and high efficiency, right? It has very less losses and it provides a high efficiency. Then it is compact, okay, and it requires less maintenance. Right? So these are all the advantages of electrical drive. One more main advantage is like it can be started instantly with full load. It does not require any warm up time, right? So it can be started instantly and it can be loaded fully immediately, right? And also it provides a very smooth acceleration and deceleration. It provides smooth acceleration and deceleration. Similarly, the regenerative braking operation, as I said, the 4-quadrant operation, the fourth one is regenerative braking operation also provide power saving. That is, the power will be fed from the load to the source, okay? So energy saving is also possible during regenerative braking. Right? So these are all are the advantages of electrical drive system, right? Next, we can see the basic block diagram of an electrical drive. The first block of any drive system, it is power source. And the next block is power modulator. And the power modulator in turns feed the motor, which is going to supply the load. And from this motor, we are going to get some inputs by using sensing unit, which in turns feed the control unit, which in turn varies the parameter in the power modulator block. So this is the general block diagram. Block diagram of electrical drive system. So first, to start with power source. As you all know, we have two types of, since the input is electrical, we have two types of supply, AC supply and DC supply. Again, in AC, you have single phase and three phase. So single phase AC supply are used for low power application. And three phase AC supply are used for high power applications. right? And again, it is available, for example, 3-phase supply. It is available in the voltage range of 3.3 kilowatt, right? Then 6.6 kV and all. And DC supply, we are getting it by using batteries. They are available in various range like 6 volt, 12 volt, 24 volt and 48 ohm. Depending upon our application requirement, we need to choose the power supply. And next comes the power modulator. So first we need to know about what is the main function performed by this power modulator, the functions of the power modulators. Okay. So the first function is like it modulates the power flow from the source to the load. Okay. It modulates the power flow from source to load. Secondly, during transient operation, as far as drives are concerned, the transient operation means it is during the starting, braking, or speed reversal and all. Okay. So these are the transient operation related to drives. So during the transient operation, there will be excessive current. We need to limit this excessive current within the permissible value, or else it will damage the drive system. So this is performed by this power modulator. It limits the motor as well as the source current within permissible value, especially during transient operation, right? So during transient operation, this power modulator will limit the motor as well as the source current within the permissible value. This is the second function. And thirdly, it transforms, or it transfers the input energy into the form of energy which is required by the motor. Okay. It transfers the, or transforms input as suitable for motor. For example, I'll tell you one scenario where in my drive system, I am going to choose an AC motor. Okay, so the motor is AC. But the power supply which I have is only DC. Okay. So this power modulator's job in this case is to convert this DC into an AC so that it is suitable for this AC motor. So in this case, in the power modulator block, I need to choose a converter which converts DC into AC, DC to AC converter. So DC to AC converter is nothing but it is an inverter block, right? Similarly, the vice versa also. Sometimes the input supply which is available is AC, but we might need to run a DC motor for our load. So in that case, you need to use AC to DC converter. So this is the main function, that is, it transforms the input energy. It converts it into a suitable form of energy which is required by the particular type of motor which you are choosing for your application, right? And the next function which is performed by this power modulator is like, it is used for selecting the quadrant of operation. It is used for selecting the quadrant of operation. As I said, we have 4 quadrants, that is forward motoring, forward braking, reverse motoring and reverse braking. So by using power modulator, we can select the quadrant of operation, whether I need to do motoring operation or I need to do braking operation. So all these are the functions of a power modulator. Okay, now let's see what are the different kinds of power modulators available. So in this power modulators, the first power modulator, there are different types, and the first type is converters. The second type is variable impedance. And third one is switching circuits, right? So coming to the converter part, as I said, my input is DC and my motor is AC. In that case, I need to use DC to AC converter, which is nothing but inverter. So in this inverter, we have various types like stepped wave inverter, PWM inverters. The main disadvantage of stepped wave inverters are harmonics, which can be reduced in this PWM inverters. So the design engineer has to choose a proper power modulator for designing a drive system. And the second one is like, and other types of inverters are also available, voltage source inverter, current source inverter and all. The next type of inverter is like AC to DC, right? AC to DC converter. That is, if my power source is AC, but the motor which I am going to choose here is a DC motor, in that case, the power modulator should be a AC to DC converter. So AC to DC converter, it is nothing but a rectifier. So there are different types like half wave rectifier, full wave rectifier, then dual converter. By using dual converter, 4 quadrant operation is possible, right? Again, here also you have single phase and 3 phase. As I said, single phase is used for low power drives and 3 phase for high power drives. Okay. So the other types of converters are DC to DC converter. Right? There are different types of DC to DC converter available like buck boost, cuck and all. Other than that, we can use chopper also. Choppers, we have various type. Class A, Class B, Class C, Class D and Class E. Class E chopper provides 4 quadrant operation. So choppers, and then in some case I want to convert fixed AC into a variable AC, that is AC to AC converter, right? So AC to AC voltage conversion can be done by using auto transformer, then AC voltage controller. Again, this AC voltage controller are of two types, half controlled, fully controlled. Using half control, you can provide only motoring operation. You need to go for fully control for both motoring and braking operation. If I want to vary both voltage as well as frequency, that is for V by F control, if I want to choose a converter which converts both voltage as well as frequency, then I can go for a cycloconverter. It is a single stage converter which varies both voltage and frequency. Okay. So these are the various types of converters which can be used as a power modulator. Okay. So depending upon our load requirement, we need to wisely choose the power modulator or a power converter, which is otherwise called as power processing unit. And I said the second type of power modulator is variable impedance. While discussing about the function of power modulator, the second point which I discussed is the main function of power modulator is to limit the motor current and the source current within the permissible value during the transient operation like starting and braking. So this is done by using a variable impedance. Variable impedance is nothing but variable resistor and inductor which is inserted into the circuit. That is variable impedance. Next come the switching circuit. So what are the various functions performed by this switching circuit is by using the switching circuit we can prevent any malfunctioning. It will disconnect the drive system for protection, okay? During any mal operation, we can disconnect the system. That is one function performed by switching circuit. And the second function is like for choosing the quadrant of operation, we'll be using switching circuits, okay? And also to make the drive to operate in a particular predetermined sequence. Like if you have, you can just correlate the automation which has happened in any food packing industry. You would have seen a conveyor moving with a container and it will be moving at a particular speed, and near the filling station it needs to stop for some 2 to 3 minutes for the food items to get filled inside the container, and after once it gets filled again it will start moving in the container. So it is a predetermined sequence. For that predetermined sequence and all, sequencing and all, we need this switching circuit, right? So these are the various types of power modulators which can be chosen as per our requirement while designing an electrical drive, okay? So this power modulator is going to feed the motor, electric motor. As you all know, there are various types of motor available like DC motor and AC motor, okay? In DC motor you have shunt motor, series motor, compound motor. Then in AC you have induction motor. Induction motor you have two types, squirrel cage, then slip ring induction motor, then synchronous motor. And also some special types motor like BLDC, switched reluctance motor, stepper motor are also available, right? Again, based upon the type of motor which you are going to choose, we name them as AC drives or DC drives. If you are going to use a DC motor, then we call that as DC drive. If you are going to use an AC motor, then it is called as an AC drive. So, based upon the load requirement, we are going to choose the motor. And this motor is going to supply the load, and this load can be a fan load, or it may be a centrifugal pump or lathe machine, or it may be a robot, anything, okay? So to have a precise speed control, again we need a closed loop system. For a closed loop system, we need to sense the output parameter and we need to correct the error, right? So in this control unit, you will be giving some reference, okay? So here, as far as drives are considered, we are going to sense voltage, current, speed, or in some cases the position of the shaft position, okay? And these parameters will be compared with, again, the voltage reference or current reference or speed reference. And the controller is going to minimize the error, okay? And the output from the controller is going to vary the firing angle or triggering angle. In case of converter and duty ratio, if it is a chopper. By varying this alpha or duty cycle D, we can vary the output voltage of this power modulator, which is going to feed the motor, okay? That is the control unit. So this is the general overview or general block diagram of any electrical drive system, okay? Next, we can compare, as I said, depending upon the motor used, we have two types of drives like AC drive and DC drive. So let us make a comparison of this AC drive and DC drive. Due to presence of commutator, it will be bulky and costly. Whereas here, there is no commutator, so compact. The second thing is the control and power circuit will be simple. Here, control circuit will be complex, right? Thirdly, it requires frequent maintenance. DC drives require frequent maintenance. Here only less maintenance is required. DC drives, the next comparison what we can tell is like a DC drive, it is not suitable for all environment. But AC drive, it is suitable for all environment, like radioactive environment. It can be immersed inside a liquid, right? Like this, it can be operated in any environment. And lastly, we can say the speed and torque range has limitations due to commutation. Here there is no limitation, no upper limit for speed, torque range. Here wide range of speed control is possible by using both conventional and solid state drive method, whereas in AC drives, the conventional method, there is some limitation in the speed range, whereas by using a solid state drive control, the speed limits are larger. Okay, so this is a basic comparison between a DC drive and an AC drive, right? To consider while selecting a particular drive, or what are all the basic requirements we need to get before getting into a design part. Okay, so factors. First one is steady state. We need to collect the steady state requirement. Steady state requirement means speed range. How much speed range? Then speed regulation. Old permissible voltage fluctuation. Okay, torque. Okay, all these things comes under steady state requirement. Transient requirement includes the acceleration value, acceleration as well as deceleration, acceleration as well as deceleration values, right? The transient requirement, we need to know about the acceleration and deceleration values, and speed reversal as well. We need to know whether it needs a very precise control, okay, any particular sequence need to be followed, all these things. And thirdly, the third requirement is about the source, availability of source. Okay, and the fourth thing which we need to keep in mind is always the cost, both the installation cost as well as the running cost. And fifthly, we need to know about quadrant of operation. Like whether it needs both motoring or braking, like forward motoring or reverse motoring or forward regenerative braking is required. So quadrant of operation. So these are all the factors which we need to consider when you start to design any electrical drive system. So thanks for listening. Thank you.